The blast furnace. For over 125 years, the blast furnaces of the Lehigh Valley made the iron that helped build and defend America. Here's a look at the iron-making process as it was in the summer of 1995. The PB&E Railroad delivers rail cars loaded with raw materials to the ore yard. Each car is loaded with up to 100 tons of iron ore pellets from Canada or limestone from Annville, Pennsylvania. An electric mule engine moves the cars up to the tip. One car at a time is placed in the tip for dumping. The tip holds the car securely and turns it over, dumping the material onto a grate. Empty cars roll out of the tip, are coupled together, and are positioned by gravity on holding tracks to be picked up by the railroad and returned to the dock or quarry for reloading. Pellets and stone drop from the tip onto a belt below and are loaded out into a side dump car. The side dump car places the material in a trough where it can be reclaimed by the ore bridges. The two ore bridges are each 578 feet long and can place raw materials anywhere in the 11-acre ore yard. Material is stocked in the yard for use as needed. The yard can hold enough ore and stone for 4 to 6 months of furnace operation. The bridges can load material from the yard directly into the transfer cars or onto the ore yard conveyor. The conveyor carries material to the top level of the track hopper building, filling the bins below. The bins discharge into bottom dumping transfer cars, which typically carry a load of more than 125 tons. The transfer cars move raw materials from the ore yard to the furnace trestle, a run of nearly a mile, most of it over elevated track. At the furnace, the transfer car discharges its load into the stockhouse bins below the trestle. Coke comes to the trestle by railroad from the Bethlehem Coke Works. It too is discharged into stockhouse bins. In the stockhouse, pellets, limestone, and a mixture of recycled steelmaking byproducts are pooled as needed to be charged into the furnace. When a stockhouse gate is opened, the material drops into the scale car below, loading it to a predetermined weight. The scale car then moves to the ore chutes and discharges the material into the skip tubs, which carry it to the top of the furnace. Coke is discharged into the skip from weigh hoppers, which are filled by a computer-controlled system that takes into account weight and moisture content. The two skips are raised and lowered by a powerful electric skip hoist located at the base of the furnace. Although various improvements have been made over the years, this hoisting equipment basically represents pre-World War II power and control technology, yet it hoists over 800 skips per day. As a full skip goes up, the empty comes down. At the top, the full skip tips over and discharges coke, iron ore pellets, limestone, or other materials into the furnace. This process goes on almost continually while the furnace is in operation, replacing the materials burned or melted at the bottom of the furnace and maintaining a constant level at the top. Inside the furnace itself, preheated blasts of air burn the coke in the lower section. Heat and gases from the coke rise through the furnace and reduce the iron oxide pellets to iron, which then melts. As the liquid iron builds up in the hearth at the bottom of the furnace, it is periodically cast and taken to the steelmaking furnace. Impurities from the ore, ash from the coke, and fluxes melt and are removed as slag. All the while, the process of adding raw materials at the top of the furnace continues. The blast of hot air for our blast furnace is generated by the engines and turbo blower in the powerhouse. The cold blast is piped to the stoves, which stand beside the furnace. The stoves burn natural gas and byproduct gas, heating the blast to 1600 to 1700 degrees Fahrenheit. There are 3 stoves at the furnace. Stoves are rotated from gas firing to blast about every 90 minutes. A hot blast line carries the heated air from the stove to the bustle pipe, which surrounds the furnace near its base. 18 tweers, branching off the bustle pipe, inject the hot blast into the furnace. A view through the peep sight shows the combustion taking place inside at nearly 4,000 degrees Fahrenheit. Water sprays cool the furnace jacket to keep the furnace structure from distorting in the intense heat. The tweers and other internal coolers were made at Bethlehem Structural's brass foundry of high-purity copper for maximum heat removal efficiency. The furnace is opened by drilling 5 feet through the clay plug in the tap hole. The furnace is cast approximately every 2.5 hours, and each cast produces about 275 tons of molten iron. The iron flows through a trough in the cast floor and into runners that direct it into the hot metal ladles placed beneath the cast floor. In the latter portion of the cast, the slag flows with the molten iron, but is skimmed off the top of the trough. Slag runs into cinder trucks, also beneath the cast floor. At the end of the cast, the furnace is closed in with the mud gun, and molten iron again accumulates in the hearth. The railroad takes the ladles to the steelmaking furnaces or foundries. Slag is taken to the slag dump for further processing. During furnace operations, particular care is taken to protect the environment. Furnace gas is captured, cleaned, and recycled to the stoves and boiler house. Water used to clean the gas is filtered in the door plant to remove flue dirt and recycled to the scrubber. Throughout the blast furnace department, from start to finish, maintenance and equipment repair play a key role in keeping the operation efficient and productive. These are the sights and sounds of iron making at Bethlehem in the summer of 1995. Best wishes to all the men and women of the blast furnace department, in the ore yard, powerhouse, furnace operations, equipment repair, maintenance, and the offices. A special thanks to all those people who have supported us, supplied us, consumed our products, and in any way helped keep the fire lit all these years.